here you see have two hydroxyl function, but you can have aromatic compound. You see here, you see between the center one, resorcinol, orcinol, or glycinol, compared to catechol and pyrogalol. You try to look at what is the difference between these two substances. Okay, resorcinol and catechol, whereas in catechol, the function is adjacent to each other. 1, 2, 3, okay? Whereas in resorcinol, the function is alternate, okay? 1, 3, and 5. Okay. Okay. This 1, 3, and 5, okay? So, because this hydroxyl function or substituent, they come from the way how the compound being biosynthesized. So in the synthesis, in the biosynthesis of phenol or phenol of polyphenol, there are two ways whereby this substance can be biosynthesized. One, by the shikimic acid pathway. Okay, I'm not sure you have learned what is shikimic, because in shikimic acid pathway, but the biosynthesis start with shikimic acid, which the OH function is adjacent to each other. Whereas in this one is synthesized by acetate polymalonate pathway. Later on, I will show you what are these two different biosynthetic process. So that is similar to the rest of the structure below. Okay, this one and this one. This is from shikimic acid pathway. This from shikimic acid pathway because 1, 2, 3 Jackson. Okay, this 1, 2, 3. This one, this is from shikimic acid pathway adjacent. So this is from shikimic acid pathway also. So many are from shikimic acid basically. Syringic acid, isovaleric acid, salicylic acid, autoprotoquick acid, hydroxybenzoic protoquick, vanillic acid. All these substances are found in fruits and in plants, in fresh plant. So when you take an apple, you cut the apple, you leave it outside. Then after a while, that is the definition of phenolic, okay? Phenolic substances tend to be water soluble since they most frequently occur combined with sugar as glycoside and are usually located in the cell vacuole. So in order for the plant to stabilize this simple phenol, the plant will attach these phenolic substances to compounds like a simple carbohydrate, to a protein, to amino acid, and so many other things. So this is how the plant keep themselves protected from the phenolic substance while in the plant, in the tissue. But when you cut, then the enzyme are all exposed, then the reaction take place, causing the phenolic substances to polymerize, become bigger molecule. Okay. Among the natural phenolic compound, which over 1,000 structure are known. Flavonoid form the largest group, but simple monocyclic phenol and phenyl propanoid and phenolic quinone all exist in considerable numbers. Okay, so another group that is beside from the simple phenol, you have the flavonoid substance which are colored. Okay, which I see in the picture just now. Photo. And then there are also non-colored substances, which is a flavonoid, and some other structure compound. And while the function of some of these phenolic compounds are well established as lignin, structural material for the cell wall, endocytin as a flower pigment, and some other other material. Okay, so for example, tannin. Tannin is a polymeric phenol. They are important because they are used to do the tanning of the leather. You know the shoes that you wear, if they are leather, they might have been tanning to protect it from get rot. Okay. So that goes to the fishing net. The fishing net, they are dipped into a tannin solution to protect and keep the net life longer. So besides that, flavonol, for example, appear important in regulating control of growth in pea plant. Flavonol can control regulation of growth, and they're present in spinach, chloroplast, has suggested that they involve in photosynthesis. Now we look microphenol, bioavailable phenol, plant phenol, low molecular weight phenols, and phenoloids are class of natural product. Okay, they are one class of natural product. They are small molecule containing more phenolic groups. These groups are small in size than polyphenol, containing less than 12 phenolic groups. Simple phenol with only one phenolic group, or bi, or tri, or oligophenol with two or three or several phenolic groups respectively. They can be found in plant and have antioxidant activity. They are most widely distributed class of compounds, and thousands are found in nature. So some of the phenol which I already showed you structure, like pyrocatechol, pyrogalol, rososinol, chloroxinol, they have some biological function basically. So natural phenol composition are normally limited to carbon, hydrogen, and oxygen in undefined proportion. Okay. So if a compound, a phenolic compound contain nitrogen, it classified as alkaloid or some nitrogenous substance, okay, or amino acid. Okay, so phenol is basically nothing more than carbon, hydrogen, and oxygen compound. As a class, they do not contain nitrogen element characteristic of amino acid, catecholamine, hormones, or alkaloids. Okay, this I already explained to you. Now we look at the different carbon number. Simple phenol, we start with 6 carbon number and aromatic structure. C6, number of phenol, cycle 1, simple phenol, benzoquinone, or hydroxyquinone, which I have already I've shown you the structure. Catechol hydroquinone 2,6-dimethoxybenzoquinone. These are some of the simple example of simple phenol. So some of the simple phenol, they are being used in the suntan lotion, suntan lotion, because it helps to trap the UV light and cause tanning of the skin. So this is some of the use of the simple phenol. Okay. Then there's a phenol with C6, C1, not C11, that one. Okay. The C6, C1. That means 1 carbon. Called phenolic acid or phenolic aldehyde. Gallic salicylic acid. Say gallic from gallic, salicylic acid. They are formed in many plants. They produce the salicylic acid. In fact, they are important as anti-inflammatory activity. And then the other group, 8 carbon, C6, C2. Example, acetophenone, thyroxine, phenyl acetic acid. So these are C8, C9, C6, C3, hydroxycinnamic acid, phenylpropene, coumarin, isocoumarin, or chromones. Okay. In this group, the coumarins are the class of compound which have a good smell, good aromatic smell. So, example, caffeic acid, ferulic acid, myristic acid, eugenol, amblyferone, esculatin, bergamot, eugenin. These are volatile substances, and also they have very strong aromatic smell used in making perfumes. C6, C4, naphthoquinone, for example, jagulone or plumbago, they are very good antiseptic compound. And also they are yellow in color usually. So in the past, they use as antiseptic. Today also they are traditionally used as antiseptic. Then C6, C1, C6. See the number of carbon, C6, C1, C6. The xanthanoid, mangiferin. These are a type of compound, mangiferin from manggis. From the skin of the manggis, you see purplish, dark color, black. That is mangiferin. So today, mangiferin are used in cosmetic as anti-aging. C6, C2, C6, stilbonide, anthraquinones, resveratrol, and amodine. These are also antibiotic, imodine, resveratrol. So these are anthraquinone. I did not show you the structure here. And then chalcone and flavonoid, isoflavonoid, neoflavonoid, example quercetin, cyanidine, gencitin. These are example. These are the class C6, C6, C3, C6. So these are substances found in nature in all plant extract. If you extract plant, you boil plant, this compound will get produced, and they are dark color, dark yellow to dark black color. Lignan, leonant, these are the basic structure, phenol, resinol, and eucydrin, that form the structure of wood. Wood is formed from this compound. Biflavonoid, emantozoflavone, for example, they are not much medical use, but they are used traditionally as a therapeutic agent. Lignin, catechol, flavone, and these are all polyphenols. Again, they are all the different type of polyphenol that become the building blocks for the structure of wood. That's why the wood, the tree can stand many hundreds of meters just hold by phenolic substances. Whereas if you look at our building, we have strong concrete. We can make the twin tower. But the tree can grow few hundred meter by building structure using simple phenol. So here are the examples of some of the structure of simple phenol which are polymerized to form hydroxycinnamic acid, coumarin. This is coumarin, which I think I told you they have like sorelin. They are used in cosmetic for to protect against UV lights in suntanned creams. Amblyophenol and so on, scopolamine. There are some flavor aromatic substance found in cosmetic. And the rest, these are the compound here. They are in the structure of wood, whereas eugenol and this compound here, eugenol, these are aromatic substance found in volatile oil. In fact, isoeugenol is a substance which is an insect attractant. So if you have isoeugenol on your body, the insect will follow you. Not the man or the woman, the insect. Okay. Property of different flavonoid. This is to this lecture is to highlight to you the different types and different flavonoid, so that after you understand the basic structure, when I mentioned to you the biological function, then you understand what I'm talking about. Okay. So property of different flavonoid classes, the anthocyanin distribution. There are scarlet, red, mauve, blue flower pigment also in the leaf and other tissues. Okay. So these are the colored substance, anthocyanin, found in wine, in fruit juice, in roselle. So water soluble, they are water soluble. These are the characteristic absorption in the UV light. Okay, leucoanthocyanin mainly colorless in hardwood, in woody plant. Flavanol mainly colorless co-pigment of both cyanic and acyanic flower widespread in the leaf. Flavone, as flavone, they are found in many plants as light yellow color substance. Glycoflavone is the same also. Biflavone, colorless, almost entirely confined to gymnosperm. Chalcone and urons, yellow flower, occasionally present in other tissue. Flavanones and isoflavanone, these are found in fruits and in leaves, in citrus. Isoflavone colorless, often in the roots, only common in the family of Leguminosae. So Leguminosae is a plant with the the fruit like petai. You know petai? That is a legume. Okay. Flavonoids are phytochemical compounds present in many plants, fruits, vegetables, and leaves with potential application in medicinal chemistry. Flavonoids possess a number of medicinal benefits, including anti-cancer, antioxidant, anti-inflammatory, antiviral property. They also have neuroprotective and cardioprotective effect. This biological activity depend upon the type of flavonoid, mode of action, and its bioavailability. These cost-effective medicinal components have significant biological activity, and their effectiveness has been proved to variety of diseases. The most recent work focused on the isolation synthesis of their analog and their effect on human health using variety of technique and animal model, which I will describe later. Thousands of flavonoids have been successfully isolated, and this number increases steadily. We have therefore made an effort to summarize the isolated flavonoid with useful activity in order to gain a better understanding of the effect on human health. So men are born with the phenol around them as coloring substance for beautifying the environment, as food substances to protect ourselves from oxidation and from diseases, fungus, virus that might have potential to attack human being or animal. So we are naturally protected by the colored substances found in nature without us realizing their importance. So these are example the most colorful substances. Anthocyanin, you look at the anthocyanin there. So if you look at anthocyanin here, plagonidine, cyanidine, pianodine, and delphinidine, butinidine, malvidine, cyanidine. These are the common types of anthocyanin that we can get in nature. You look at the structure. There's a positive ion there, yeah, which make it very soluble in water. But we must also understand there's another compound called betanin or betanidine. Look here, they are not anthocyanin. Okay, betanidine. So betanidine are found in the colored dragon fruit, the red dragon fruit. So dragon fruit is not containing anthocyanin. The colored substance found in dragon fruits is basically bethanidine. But they have similar function to anthocyanin because of the structure. But the difference is that these have got a nitrogen, so they are not. They might be classified as alkaloid, okay? But because they have also an H group here, so they are classified under the nitrogenous substances. So they are very strong colored, reddish, purplish color, usually. These are found in dragon fruit. So anthocyanin are the most important and widespread groups of coloring matter in plants. These intensely colored water-soluble pigments are responsible for nearly all pink colored, scarlet, red, mauve, violets, and blue color in the petal, leaf, and fruit. So if you want to keep healthy, you must drink. That's why I always say drink colored juice, eat colored juice, because they are possibly contain anthocyanin. Okay. The anthocyanin are all biochemically on a single aromatic structure, that of cyanidine, the structure which I told you earlier, all derived from the pigment and addition, subtraction, hydroxy group, or methylation. So on the structure of the simple phenol, anthocyanin, the different substituent here, or here, this one, this one, this one, this one, and so on. Different, it can be OH, OCH3, or a glucose or some other compound that will change the color of the anthocyanin. So the color of cyanin depend on the attached substituent to the structure of the molecule. Anthocyanin are all chemically on a single aromatic structure, that is cyanidine. So the basic structure is cyanidine. Are all derived from this pigment by addition of saturation of hydroxy group, or methylation, or by glycosylation, which I've described to you what it's all about. There are 6 common anthocyanidine. Anthocyanin and glycone form when anthocyanin are hydrolyzed with acid. The magenta color cyanidine being far the most common. Orange red color are due to Plagonidine with less one hydroxyl function group than the cyanidine, while mauve, purple, and blue color are generally due to delphinidine, which has so here, if you look, the different say, uh, different structure give different color. Okay. Delphinidine and cyanidine, to a much less extent, plagonidine may also form in acid hydrolyzed plant tissue from colorless polymeric tannin present from the compound. So plant also contain a lot of tannin. Tannin is polymeric phenol. When you hydrolyze them, they will release some of the cyanidine or delphinidine, some of the anthocyanin. Okay. So the production of anthocyanidine in this way constitute the main methods of detecting this color substance in plant. So here is a different types of different other types of structure of flavonoid, which I mentioned earlier: the flavone, the flavonone, the flavan, the biflavonoid. Biflavonoid means two molecule of flavonoid dimerized like this. So these are some of the possible structure of flavonoid that become open up. In some cases, if you notice here, the isoflavone, when usually these are here at this position, but in this case they move to this position. So these are this class of flavonoid is called isoflavonoid. Okay, so isoflavonoid is flavonoid where the aromatic structure here move from position 2 to position 3. There's a simple mechanism. So they produce different classes, but they're not common. But they produce different classes of compound of different colored substances as well. And if you look rotinone, rotinone here, these are very important insecticide. These are derived from flavonoid, okay? You see from here, isoflavonoid. Here they form a ring, and now it become rotinone. Rotinone are insecticide that you find in the pokok tuber, pokok tuber, or scientific name Daris. In Malaysia, there is a Daris elliptica, where in the past they extract rotinone and used to spray insecticide. 100 years ago, when people don't understand other types of insecticide, the 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 English people came to Asia to collect rotinone and use them as insecticide. But today we have better insecticide derived from alkaloids. Okay, so our times are coming up. So here some other information related to the flavonoids. Okay. The last part which I want to share with you is how the polymeric substances are formed. These are example of how polymeric substances are formed. A simple phenol lose an electron and they become polymerized this way or this way. Okay, these are, we can use this by chemical means, but in plant they are act of nature, where the enzyme phenolase help to cause this polymerization. Okay, so through this polymerization, coupling of phenol, they can form different structure like this one. These are apophyl alkaloid, or orientanone, which is another type of alkaloid, benzyl isoquinoline alkaloid. You should learn this from in the alkaloid section. Coularine, this is another polymerization process of a phenol. From coularine, coularine is a arrow poison. Amylase alkaloid, through acid form also different complex structure. Erythrina alkaloids also process of polymerization, restructuring. These are condodendron tomentosum, which produce alkaloid for the arrow, curare, used by the Indians to capture their animal, okay, by the arrow. Okay, thank you very much for listening.
Thank you, sir.
Okay, any question? Actually, I like to teach direct in the class. Then I can interact. Now I have my former student now, they are directors and professors. They teach the way I teach also, my knowledge. But maybe I have more knowledge than them. But interesting, over time, you realize time goes fast, so fast. We have to deliver knowledge through like this, okay? In the future, I'm not sure what the university going to be. Is a digital university, maybe. You don't have to go to class, you just take courses from the internet and you get your degree. Do you think that is possible?
Who knows?
Okay, thank you for listening.
Okay, thank you very much, Prof. Muhammad Zakaria, for his lecture. Okay, I hope that you have already, understand a little bit on phenols. Okay, so it's different when we, listen lectures from a professor, isn't it? Anyway, okay, so time's up. Professor Muhammad will be sharing a few more lectures later after the mid-sem break. Okay, so I think another 2 lectures. Okay, so we'll be having him again. So in the meantime, if you have any questions, maybe you can try to think what questions you want to ask him, and what are the possibilities of of work later, because now you're only in your second year, isn't it? So later you go out and work, you should know what is the possibilities, or what can I do if I learn this, so maybe you can ask him later. You ask him a lot of questions, okay, because it's not easy. Not all classes have elite fellows. For this semester, we have phytochemistry. The only, not the only, I'm not sure. The only subject that has an elite fellow, right? So you are very lucky today to have Prof. Muhammad, lecturing all of you, okay, as he's the pioneer of this of this class. Okay. Anyway, thank you very much. So I'll see you. We'll see you next Thursday. Wednesday. I'm not sure. You'll be. I think Dr. Suja will still be teaching all of you. Okay, and then I'll be teaching you for the half. For the coming after the mid-term break. All right. So don't forget to take your attendance in Spectrum. Okay, and I'll see you after the break. All right, with more phytochemical compounds. All right, see you guys. Thank you very much for attending today's class.
Thank you, Doctor.
Thank you,
Thank you,
Doctor.
Doctor and
Thank you,
Prof.
Doctor.
Thank you, Doctor and Prof.
Thank you,
Thank you,
Prof and
everyone.
Doctor.
Thank you, Prof.